Hello, welcome back. We're going to continue looking at Laplace equation on a rectangle. So far we've looked at two examples when we had three sides of the rectangle were 0, quantity was 0. In this video we're going to have two that are 0, two that are non-zero. Two functions, right? So how would we go about doing this? So whenever you have a problem like this where you have more than one function or value on the outsides, you have to do what's called linear superposition. So for example, in this problem, what you would do, for this problem, we would first, for this problem, we would turn, or for this problem, we can turn it into two problems. One case where h of x is 0, and another case when f of y is 0. And then what you do, and then, add solutions. That's known as superposition. And we can do this. I can only do one thing at a time. Before we do this, the reason why we can do this is because the Laplace equation is linear. So far, we've only been looking at linear PDEs, and this is no exception. So we can linearly superimpose the solutions. So what we're going to do, this is on my previous work here. Let me just delete this. We don't need this. I'm going to put a line down the middle, and we're going to do the two solutions next to each other. But because we've already done two examples already, we should be able to easily shortcut our way through this problem. So let's look at the case first where f of y is 0, because if f of y is 0, then this problem is exactly the same as this problem that we did for example 2. So what I would do is say, fy is 0. If f of y is 0, we have these other boundary conditions remaining. Right? So then we already know what the solution is to that one. Exactly same solution as number 2. Well, example 2. So we don't even have to do that part. Now for the second one here, we have h of x. H of x is 0. If h of x is 0, then we're going to be left with x of 0 is 0, y of b is 0, and y of 0 is 0. So this one's going to be a little bit different than what we've been doing. For this one, we have to do a boundary value problem with the y equation. Use the x to solve for x. And then a and b are going to be flipped for this one because it's on the other side of the rectangle versus what we've been doing. So I'm going to use that knowledge. I just simply flipped the same kind of mathematics. The same is still direct. It's still the same boundary conditions as number 1 up here. I didn't write the boundary. Okay, well, except the fact that it's going to be basically on the other side of the triangle. So what we're going to do for this problem is we can simply, it's just, so let me write this, similar to number 1, just flip A with B and X with Y, if that makes sense. So I'm going to go ahead and copy that solution. For the superposition here. So this is the first half, so we're going to flip A with B. Put this on the other side of the triangle. And then flip X with Y. That makes sense. It makes a lot of sense. And this is not going to be G. They used F. This is an F. Y. And that would be X. Just checking my answer, making sure it's right. Looks right to me. Okay. And then for the second part, this is exactly the same solution as number 2. Nothing changes. It's this right here. But I don't have C of n plugged in. Let me copy. I'm going to have to plug in Cn there. I'm going to move all this over. Actually, I'm just going to move... What's C sub n? I'll just copy this. Move all this over. Move this over. Paste. Shrink that down. Here. That's our answer. That's it. We just superimpose those 2 solutions. Now, what if we had... Now, before I continue, don't get me wrong. You could always go through and solve these yourself if you want to verify my answer. But if you've already done example 1 and 2 before, you can kind of look at it and be like, oh, I know how to do this without even doing it. But you can always go through it. What if we had more than 2 non-zero boundary conditions? Well, if 3, you just superimpose 3 solutions, and so on. And what I mean, like if you have 3 of them, you'd have to set 2 of them equal to 0, and then you solve with the other one. And you do that 3 times. Set the 2 equal to 0, solve the other one. And you just do all 3 of them in one problem, which is kind of annoying. That's basically 4 problems in one. That would suck. That's how you would do that if you're wondering. So I thought this was an interesting case to do. It's a very interesting solution. You know, this is very different from the other stuff we've been doing, I guess. Laplace equation is interesting. So that's the end of this video. Only 10 minutes. That's very good. Next time we're going to have, let me look here. Looks like it's a whole Newman problem. Yes, it's a full Newman problem next. So it's all derivative boundary conditions is the next example. And then the one after that is a mixed between the two. So I will see you in the next video. I hope you enjoyed.